Okay, ladies and gentlemen, welcome back to Module 6 now. We're going to talk a bit about the digestive system, energy production, and calculating energy intake. Okay, within this video, I'm going to talk about the components and function of the digestive system very quickly. The fate of macronutrients, so whether they're used as a fuel, whether they're stored, and sort of some of the structures and intermediates that are involved in metabolism, so you can sort of see the flow of macronutrients and how they can be converted from one form into another. Give you a good understanding of energy pathways. And then we're going to talk a little bit about the basic principles of structuring a diet, so calculating a starting point, calculating how much protein, carbohydrates and fats, from a perspective, more of a bodybuilding perspective, but this can be applied to any sort of sport or background that your client is coming from. So let's start with the digestive system and its function. So we're talking about one long tube starting at the mouth and ending at the anus that takes in food, processes it, removes all the nutrients that we need, and then passes out waste. Okay, so that starts with our mouth and through the process of mastication or chewing, which then obviously breaks down food, allows our digestive enzymes further down the chain and also within the mouth to actually get into the food, start breaking it down, makes it more efficient digestion and absorption process. Also adds to sort of lubricate the food, which then is formed into a bolus, so like a small food package, which we then swallow. Okay. So in the salivary glands, we've got amylases and lipases, which are going to start breaking down carbohydrates and fats already as soon as they're in the mouth. You can actually feel this as an experiment. If you take a piece of bread and you start to chew it, as the amylases start to break it down, if you keep your bread in there for a long time, it will start to taste sweeter and sweeter. So that's the glucose being released from the starches that are within there as well. So it will start to taste sweeter as you chew those things. Okay. So obviously then it passes down our pharynx, down our esophagus, esophagus. I can never say that word, down into our stomach. Our stomach is where a lot of mechanical digestion takes place. A lot of the harsher chemicals, things like hydrochloric acid, HCl are in there. And we've got lipases again, fats, a bit more stubborn, we need to break those down, and then pepsin as well to start breaking down our proteins into amino acids. Okay, so within the stomach, obviously this is an important part of digestion. A lot of people tend to get, a lot of people can have things with acid reflux, bad, poor digestion, indigestion and things. One tip that I would suggest works for a lot of people with that is to not use directly things that are going to sort of try and alkalize your stomach environment. So a lot of people will take milk and magnesium and something like that to actually kind of cool the stomach to act against the hydrochloric acid reflux. So that will tend to actually force the stomach to produce more. So try this as a tactic. Take acetic acid, which is found in normal vinegar, or particularly a tastier version, because obviously normal malt vinegar isn't great, is apple cider vinegar. So a lot of people use that for digestive help. Actually helps with blood sugar levels as well. But actually, what it does is acetic acid increases stomach acid levels to a small extent, but it acts as a trigger with which to switch off excessive amounts of stomach acid production as well. So it's a really effective tactic for anyone who has acid reflux, indigestion problems and so on and so forth. Then we've got our two glands that are near our liver and our pancreas. So we've got our gallbladder, which produces bile salts, and our pancreas, which obviously, as well as being an endocrine organ, also produces amylases, lipases, trypsin, chymotrypsin. So we're acting on carbohydrates, fats, and also proteins as well there. And they share what's called a common bile duct. Okay, so those two excrete their kind of substances, their substrates, their digestive aids into our small intestine, the upper part of the small intestine in particular, which are really going to finally break down those more specific nutrients into absorbable parts. Okay, so obviously most of the absorption then takes place in the small intestine, which is comprised of the duodenum, the jejunum, and the ileum. So by the time we get all the way down to our cecum, which is the bit where the small intestine meets the large intestine, by the time we get down there, we're going to be basically most of our nutrients have been absorbed. So what we've got left really are sort of gut flora, gut bacteria that are going to actually help extract some of the nutrients and absorb them. So things like vitamin K and some fatty acids as well. But also, most importantly, fibre in your gut is going to be there for to help reabsorb water as well. Okay, so fibre is going to help form the stool, and the gut bacteria and your colon is primary function is to actually reabsorb water. Okay, so things to watch out for with regards to the diet that can affect your sort of colon health is having too many carbohydrates or fats in one meal, as particularly with not enough water. This can be an issue with people who might use dextrin sort of pre or post workout, can cause what's called osmotic diarrhea. So basically, if we get so much carbohydrate in our body or fats in our body through food in a very short period of time, this will pass through our digestive tract, and relatively, well, not all of it, but some of it might get through unattached. And because these have these actually hold water molecules within the digestive tract or within the large intestine, it means water can't be reabsorbed. So therefore, our stools are a lot looser. So that's why people tend to get diarrhea with these sort of things, because the body's trying to get rid of it out of the tract if it hasn't been absorbed in the intestine. So if you've got all those excessive carbohydrates and excess fat sat in your large intestine, that can be an issue as well. So if you do suffer with that, start spacing out your carbohydrate feedings a little bit more, increase your water intake to help with the absorption, and so on and so forth as well. So that's something to watch out for. Obviously, another thing to watch out for as well is a lot of people, if they have slow transit, so they may only go to the bathroom maybe every couple of days. Maybe high fiber diets aren't necessarily good for those people, because actually fiber will actually, to an extent, slow the transit of that as well. So a go-to thing a lot of people do if they have stomach problems or trouble passing waste will be to go and increase fiber content, but really take a look at a person and see actually if they've got a naturally slow transit, this could be making it worse, and they might actually already have too much fiber in the diet as well. So yes, fiber does aid in digestion, and fiber is an important part of the diet, but just be aware that too much fiber can actually cause some problems as well, in terms of adding almost too much bulk to the stool, so that actually passes even slower, it may be an undesired effect. Okay, final thing I want to talk about is the appendix. The appendix is obviously classically viewed as a kind of an unnecessary organ, and it isn't. Obviously, if we have it inflamed, it can lead to appendicitis, which can be toxic and kill you effectively. So we in those situations, doctors will remove them. However, they're starting to believe now that the appendix actually might have some immune function. It's got a lot of lymphocytes within it. It might be a store for stomach bacteria, so that if we do get ill and we do get things like diarrhea, which is basically our chyme, our digested food, but with our digested and absorbed food, but without the water reabsorption. So when we're ill, what we tend to do is void our bowels very quickly, but that can actually remove some of our gut bacteria. So they actually think the appendix might be a store for gut bacteria that can actually help restore the stomach environment back to its normal environment, its normal levels, its normal sort of homeostasis quickly. Okay, so it may have something to do with that. So that's more recent stuff that's starting to come out in the literature now. So now we've dealt with how our food is digested and it's absorbed, and like I say, there's more details than that in the module outline text to get into the nitty-gritty of it. On now to macronutrient pathways. Now stick with me on this one, because this is going to get complex. There's plenty of other resources out there to learn about this stuff, so don't just listen to this if you don't understand it. Sometimes different people can explain it in a different way. There's a particularly good thing on YouTube called Khan Academy, Khan Academy. They do loads of draw through kind of illustrated descriptions of these pathways as well, probably with people who are a little bit more used to teaching it than I am. So please feel free to use those sort of resources as well. If you don't understand me, I apologise, but I'll do my best. So let's start with dietary carbohydrate, which is at the top in the middle there. So dietary carbohydrate is going to fundamentally be broken down into glucose or sugar, different sugars or chains that can be absorbed. Once it's into our bloodstream, it's got a few different fates. If we need it for energy, it can be converted into pyruvic acid or pyruvate. Okay, just on a little side note there, anything where you say like a pyruvic acid, it will also be a pyruvate. So lactic acid will be lactate. These terms are interchangeable, and I will sometimes flip between them. I'll try and use what terms are on the slides here, but be aware that sometimes it's difficult. So another one within this later on is citric acid, which is also known as citrate. Okay, so there's a few examples of that. Glutamic acid as an amino acid is glutamate. So just be aware that sometimes terms might not make sense if you're reading different papers, but it's usually the word acid is just replaced by the word ate. So pyruvic acid would be pyruvate in other resources. Okay, So sorry about that. So glucose can then be converted to pyruvate, and then under anaerobic respiration can be used to produce energy with some carbon dioxide given off. So that's the pathway going from carbohydrate straight down there. More of the carbon from glucose can then enter past that red line. Okay, now that red line is important because that's once it's gone past that point in terms of the substrate processing, in terms of our glucose molecule processing, that is a point of no return. Okay, so we can go from pyruvate to acetyl-CoA, but we can't go from acetyl-CoA back to pyruvate. Okay, so that fundamentally there, as we're talking about, is mostly anaerobic metabolism there. Okay, so that's very energy inefficient because we don't use up all of our glucose. Okay, so that will then be converted to lactate in that process, and then eventually that lactate will be recycled back to produce glucose or used up later on once it can be oxidized as well. Okay, so once we get past that red line, what we're fundamentally talking about there is things that are taking place inside the mitochondria of our cells. So that's our energy producing power plant. So we can produce some energy in our intracellularly, but outside of our mitochondria as well. Okay, so if you pull up the diagram of mitochondria or a normal cell, you'll see mitochondria are these small little capsules within a normal muscle cell or any cell of the body really, and they're the energy producing things that require forms of oxidation to do that as well. Okay, so glucose can then go down into our Krebs cycle. I'll talk about Krebs cycle in a minute because it can tie in all of our main macronutrients. Okay, so glucose then, if it's not being passed down to produce energy either anaerobically or aerobically, it can then be converted to glycogen. Okay, so glycogen is obviously the storage form of glucose in the muscles. I'm going to talk a little bit more about glycogen in another video, about its storage and how it's broken down, and how actually glycogen doesn't reproduce glucose, which might sound confusing, but it will make sense another time. Obviously then when glycogen is required from either our liver or immediately within our muscles, it can then be converted to glucose down that pathway to produce energy. So let's move on to dietary fat. So dietary fat, in terms of what we eat, will be in the form of triacylglycerols or triglycerides. They're interchanging. Triglycerides used to be the sort of older term, but triacylglycerols are now becoming the more more popular way of saying that. So they're known as TAGs or tags. So our tag has a glycerol backbone and our fatty acids attached to them. Again, on the fats and carbohydrates module specifically, you'll see that how these are structured. Okay, so you'll get a better understanding of this. And glycerol from that can then be used as an intermediate to be converted to glucose, which can then follow the same pathways as glucose does. Okay, so actually from this we can see that dietary fats can actually be used to maintain blood glucose levels, and this is important when we don't have carbohydrate within the diet. There's a certain level of background glucose needs to be maintained. So with our dietary fat, we can then also produce fatty acids. Now, fatty acids can undertake two things. They can either be converted to energy via a process called beta oxidation, which basically cleaves hydrogen ions off our fatty structures. So basically, when we're talking about metabolism, what we're talking about is the production of hydrogen using oxygen and using oxygen and various enzymes to actually help reproduce ATP. And they do that via the process called the electron transport chain. Okay, so if we look at the beta oxidation arrow there, we can see that the arrow goes down into the electric transport chain, and also our Krebs cycle, which is our big blue circle, also feeds hydrogen ions into our electron transport chain. Now, what this process is called oxidative phosphorylation, which takes place on the electron transport chain. And fundamentally what that does is it uses hydrogen as an energy source in the combination with oxygen to convert ADP, which is adenosine diphosphate, which is our used up form of energy, back to ATP. Okay, so if we think about ATP, we lose a phosphate, okay, and that produces ADP. So to re-energize that, we need to resynthesize ATP from ADP, and to do that we need hydrogen, which provides the energy, and then we need oxygen, and then obviously need a phosphate to attach to that. So that's why it's called oxidative phosphorylation. And the byproduct of that, as we can see there, one of our waste products is water. Okay, so the electron transport chain is quite a complex thing. I'd encourage you to go and do some reading on that. It's not essential, but fundamentally that's our energy cascade that uses this hydrogen in the kind of cascade fashion in order to actually resynthesize ATP so we can constantly produce energy. And like I say, that requires oxygen, so that's where the oxygen That's why that's a sort of aerobic metabolism takes place at that component part of the metabolic process. Okay, so we'll talk about how we get that from the Krebs cycle in just a second. So the Krebs cycle is that blue circle with the arrows going around it. It's also known as the tricarboxylic acid cycle. It's also, or the TCA cycle, or the citric acid cycle, or the citrate cycle as well. So these terms are all interchangeable, but we'll come back onto that one in a second. So from our beta oxidation, we can also get a little bit of input then to create acetyl coenzyme A. So we get some substrates from that can then actually go into the Krebs cycle directly. But obviously then this can't be converted back up to glucose at this point, because as we see, we've got a big red line which is stopping that taking place. And then obviously then fatty acids can also be stored as adipose tissue. So they would float around the body. Well, they're packaged in the liver in things called chylomicron tag. And then, sorry, I confused myself there. And then they then cycle around the body until they reach adipose tissue, and then they're then stored. So the glycerol is then removed. They're then taken inside the adipose tissue and then recombined with glycerol as well. So they're stored as triacylglycerides. And then when we want to release this through the process of lipolysis, okay, that lipolysis then removes the glycerol again, which can then, I think, be converted to energy. Don't quote me on that one, look that one up. But then basically then you get your fatty acids, which are non-esterified fatty acids, are then released, that are then packaged in carriers again, and then shipped off to the tissues to be oxidized for energy. Okay, so we've dealt with fats now, and now we're going to move on to amino acids. Now amino acids are quite an adaptable macronutrient in a lot of ways, because obviously we use it for protein synthesis, so not just protein synthesis for muscle, but also things like creation of enzymes. Various membranes and structures throughout the body are made up of amino acids, and obviously we get them from dietary protein. Okay, so what happens with amino acids is then when they're used up, we get our amine group removed, which is the NH3 group that you'll see attached to amino acids when you look at the structure in the amino acid module, and that is then excreted as ammonia in our urine or urea. Okay, so that's our two of our waste products sorted. So we've got urea, and water as well. So we've got urine and we've got water, but the urine in that sense contains obviously this ammonia, this toxic ammonia from our amino acid breakdown. Okay, so amino acids then can not just be used for protein synthesis, but they can certain glucogenic amino acids can be used to create glucose. Okay, so they can be used to create pyruvate and then converted to glucose, as we see there from the top arrow going to the 3-carbon substance there. And then also you can get other amino acids that can be converted directly into acetyl coenzyme A, so it can enter the Krebs cycle at that point as well. So an excessive amount of amino acids can be used to produce energy. So although amino acids, it's not a convenient pathway to get from amino acids to energy, be aware that in theory you could consume too many calories from protein and it will contribute to energy intake. However, most of the processes amino acids will be directed to, under most circumstances, will be protein synthesis and will be muscle protein synthesis. So it's not like every calorie from amino acids is going to contribute directly towards energy production in that fashion as well. Okay, so that's why we can get away with higher protein, and also to eat the amount of protein that it would take you to get fat. Considering all this other stuff that's going on as well, and how satiating protein is, how filling protein is, would take you. It would be very difficult to do. I'd say almost impossible, realistically, to consume the calories, especially if you were looking at actually whole food sources of protein as well. Okay, so what happens then? We've figured out now how to get to a few different ways to get to pyruvate, and actually how we can produce glucose from non-glucose sources. So what happens once we get to pyruvate? Well, pyruvate can actually produce energy directly by removing hydrogen ions. Now, it does this through a compound called nicotinamide adenine dinucleotide. So that's your NAD, and that's how I'll refer to it from now on, because saying that was troublesome. And the NAD is it's a nucleotide that fundamentally cleaves hydrogen ions. So when we look at our carbohydrate, okay, which is C6H12O6, there's a lot of hydrogen in there as well, so we need to remove those hydrogen to add it to our electron transport chain. So at that point, from pyruvate down to acetyl-CoA, we can actually remove a little bit of hydrogen and actually help resynthesize some ATP at that point. Okay, a waste product of that process is carbon dioxide. Okay, so that's our other waste product that we produce from the body. It's carbon dioxide alongside our water and our urine. So that is then converted from a 3-carbon compound to a 2-carbon compound called acetyl-CoA. This then enters our Krebs cycle, or our citric acid cycle, or our TCA cycle, or our citrate cycle. Okay. At this point, like I say, this is irreversible, and then we get a series of processes by which this acetyl-CoA then is then fed in continually from glucose going into it as well, and also from beta oxidation, the carbon that's then the carbon compounds that are then attached to fatty acid chains as well. So fats have got a lot of hydrogen and a lot of carbon, so they've got a lot more potential for energy, which is why they're 9 kilocalories per gram compared to carbohydrates and proteins, which are 4 kilocalories, just through the carbon and the hydrogen content. Okay, so the steps of the Krebs cycle once we get to citrate become very, very complex. This is the best diagram I could find that would simplify it, but if you want to go and do some more reading about the different enzymes that are involved in these processes, please feel free to do so. Citrate is an important amino acid, which is citric acid there. It's an important substrate because it's involved in the creation of fatty acids from glucose. So if we have an excessive amount of carbohydrate in the diet, and I mean an excessive amount of carbohydrate, I'll talk about how much another time. This is one mechanism by once the glucose has then entered into our mitochondria, into our Krebs cycle, that citrate actually has an enzyme that can transport it extracellularly, so it can remove it from the mitochondria elsewhere. So we do have a mechanism to withdraw energy from the Krebs cycle once it's actually started. Okay, so although we can't convert acetyl-CoA to pyruvate, we can actually remove citrate from that, and that can then actually be combined to create long fatty acid chains, which can then be stored. So we can store fat from excessive carbohydrates. But again, I'll talk about that in a bit more depth later in another module. So like you can see, we've got our NAD again. That then removes our hydrogen to our NADH, and that then enters the electron transport chain. We then get a 5-carbon compound from our 6-carbon citrate compound, and again this goes round and round and round until we've removed the hydrogen, and it's then kind of expired through carbon dioxide as well. There's another cleaver, or FAD, if you look on the left hand side of the citric acid cycle, and that does a very similar job to our NAD, except this removes 2 hydrogens as well. So that's basically how metabolism works, and that's a very basic overview. It's difficult to try and not throw all the key terms in there because there's a lot of enzymes involved in the Krebs cycle with a lot of long names which will just confuse you at this juncture, but please feel free to go and have a look at that. The main takeaway message I want you to get from this is that when people talk about different dieting strategies, our body has the capacity to adapt very effectively, or fairly effectively, to convert things from one form into another as well. And as you can see from this is exactly why that there are only 2 nutrients that are considered essential. Okay, so that's amino acids and essential amino acids, because some can be synthesized from carbohydrates, and obviously dietary fat as well, because fatty acids are essential for various other functions within the body that we'll talk about in the module that covers fatty acids and dietary fat and so on and so forth. But fundamentally, glucose and dietary carbohydrate are non-essential nutrients. Now, a lot of people would use this as evidence that we shouldn't have it. I think this is a bit misleading as a term to say it's non-essential, because the body will still create it if it's not there, okay? Because it needs a certain amount of glucose. There's a lot of parts of metabolism that can't take place without glucose because they perform anaerobic metabolism, so red blood cells and so on and so forth. Part of their synthesis involves anaerobic respiration. There's various other things in the body as well, various processes that do things anaerobically, so therefore need glucose, because it's the only thing that can effectively be used in anaerobic respiration. Okay, so please, just because it's not essential from the diet doesn't mean that it's not beneficial to use. So we'll talk about the difference between essential and beneficial as well. Remember, we're usually dealing with people who are going to be physically active. Okay, glucose in terms of glycogen, in terms of the kind of activity we're performing, then becomes essential. Okay, so hopefully that made some sense, so it wasn't too traumatic. And now we're going to move on to something a little bit. So hopefully now we're going to move on to something a bit more practical to actually help you with clients or your own diets, and we're going to talk about calculating a nutritional starting point. Now by this I mean there's a few things we need to consider. One, in terms of a pyramid of importance, is calorie intake, which is then followed by macronutrient intake, and then things like feeding timing and so on and so forth. So the most important thing to work out for our clients is their maintenance level of calories. And one of the questions that me and Neil both get asked quite often is, how do you calculate a maintenance level of calories? Now, I've put the word maintenance in little quotation mark, simply because maintenance is a fluid thing. Your body can adapt to slight increases or slight decreases in calories, okay? So things like thermic effect of food or dietary induced thermogenesis, DIT or TEF, if you want to go and do some reading about that, actually help maintain weight, even on a slight calorie surplus, but only slightly. And as we reduce calories, obviously our maintenance level of calories can be adjusted by the effect this is going to have on our hormones. So I'll delve in and out of those things as we go through this. So the most effective way and the most accurate way, I think, is to look at food diary versus their weight loss or gain. So if someone uses certain fitness or food apps that track their macronutrients and their calorie intake, you can really then get a good insight in terms of, as long as they're being honest, what their kind of calories intake is that they're maintaining their weight. And then what we can do from that is use various tools to manipulate that to our advantage. So either we can increase calories for weight gain, or we can decrease calories for weight loss, or we don't necessarily need to decrease calories for weight loss. Depending on what their food intake is, we can actually change the macronutrient ratios to our advantage. And I'll talk a little bit about that in a minute, and about how a very basic way to structure it without trying to overcomplicate it and get into the wide variety of manipulations you can make. Obviously, if you're taking a food diary just from memory, this has issues with underreporting food intake and accurate measurement as well. I mean, a lot of people one of the biggest issues with weight loss is that people think they're consuming less calories than they are, and actually when they track their calorie intake properly, when they're done in proper observational studies as opposed to just allowing them to log their own foods, they actually find that people chronically underestimate how many calories they eat. They forget about the sugar in their tea. They forget about the biscuit they had that someone brought into the office. They forget about that slice of cake they had for someone's birthday. And it might only be a few hundred calories, but that can be the difference between gaining weight and maintaining weight, or losing weight if that's the goal. Okay? If these things aren't available, if someone is completely clueless and you don't trust them to report their food intake for a period of time before you actually start working with them in terms of a weight loss or muscle gain plan, get them to use food apps for a few days. Things like MyFitnessPal. There's plenty of other ones out there which are really easy to use. Spend some time showing them those things. Or if they want to work immediately and they don't want to do this, then use the guesstimate from formulas, okay? And this is an estimate, so it's probably going to take you longer to find these maintenance calories using the formulas that are within the module text. They are quite effective, but like I say, they are very broadly dependent on a lot of different factors: genetics, people's basal metabolic rates, the other stuff they're doing as well, their activity level. So when you structure a diet, when you're talking about maintenance level, it's going to depend fundamentally on their goals as well. So if you're looking for someone who's trying to gain lean muscle tissue, you're probably not going to be looking at increasing their maintenance, that starting their point of they're starting their calorie intake point very much higher than where they are. Okay, you might just want to talk about or think about manipulating the macronutrient ratios that are in there, or amounts that are in there as well. We'll talk a little bit about how the difference between using ratios and actually using amounts may have different benefits to people in a second. So obviously another important thing then is the goals in terms of what they're trying to achieve. So you have to factor that in. There's no point giving a bodybuilder 1.3 grams of protein per kilogram and an endurance athlete 1.8, 2 grams per kilogram of protein as an example as well. There's no point putting an endurance athlete on a low carb diet, so on and so forth as well. So you're going to need to be aware of these things. So although mostly throughout this course we're talking the things from a bodybuilding perspective, bear in mind that you will have the opportunity to work with clients who are endurance athletes and so on and so forth. So always bear these things in mind, okay? For the sake of example, I'm going to talk about structuring things from a bodybuilding perspective, but throughout the module text online, you'll see that there should be amounts that are recommended for different athletes within each of the macronutrients, okay? So bear those things in mind as well. The examples we're going to use here, just for brevity, so we don't have to talk through them all, are going to be focused around a bodybuilding diet and either a maintenance calories or a weight loss from that perspective, or a fat loss anyway, because remember, we're after fat loss, not weight loss. Another thing to consider is relationships with food. Now this works both ways. Sometimes you'll have clients that can't lose weight who have basically been on a lot of cardio, who have been under eating chronically, who have really adapted metabolisms, and they're slowing their metabolism down because of the large calorie deficits they've been on for a long time. And they may be carbophobes, okay? You will find this a lot. You can't suddenly tell someone who's never not eating carbs for 6 months that all of a sudden they're on 300 grams of carbs a day because it fits their maintenance calories. They're there has to be a gradual increase of those so people have the confidence to actually eat those foods and understand the benefits they can get from it. And even then, you may be fighting a losing battle with some people, so you might have to think of other strategies, and they may have to have maybe a higher proportion of fats within the diet to provide energy than carbohydrates, because you need to be aware of these things. And you can't, diet stress, trying to stick to a diet plan is stressful enough from a psychological perspective, without also then trying to force foods onto clients. Now, if you're talking about someone from a bodybuilding prep who's in that state of mind, that's slightly different, because it is kind of do as you're told. It sounds awful, but it's true. But I'm talking about for your general health clients who are trying to lose weight, or people who've had a long-term history with food-related illnesses as well, so anorexia, bulimia, or even just mild carbophobia, as I'll call it, or fatophobia. It happens as well. You get it both ways. So just be aware of those things. And although you may have your optimum diets, sometimes suboptimal can get results, and you just have to bear those things in mind until someone gets the confidence to work with you. And once people have that confidence that you're getting the results that the way they're doing it, they will believe and trust in you a little bit more to then do those things. So you have to have a relationship with your client that means they trust you as well. That's one of the biggest things about being a good trainer, is what I will say, is having people buy into your philosophies and trust you that you're not trying to actually sabotage their physique, because people will believe that. It's a funny thing, but it does happen. And this can also happen in the other way as well, in terms of people have an overly positive relationship with food. And by that, I'm talking about people who get a great hedonic response from food. Now, hedonic response is how much you enjoy eating food. Obviously, food should be enjoyable. Dieting doesn't have to be boring. Putting on weight doesn't have to be boring. You can get healthy recipes out there. There's plenty of sites out there for those things now. However, one thing I would say is be aware of what are called trigger foods. So if you've got someone who, when they start having a spoonful of peanut butter, can't stop until they've eaten the entire jar, it's probably not best to include that on the diet plan. So these are conversations you need to have with clients before you actually structure a diet. There's also no point, again, it's slightly different for bodybuilders because they will just do as they're told, but if you've got someone trying to lose weight and they don't like a food, just because it's nutritionally beneficial or micronutrient beneficial and you like that food because it's a so-called superfood or whatever you want to call it, then that's fine. But be aware they might not eat that food, okay? So they might actually be under eating calories, which may not be the desired goal. So be aware there's usually many other foods that they might like as replacements that can go in there. So be a bit flexible with people, especially if they're starting out on this journey. Too much change is going to put them off. It's going to affect adherence. And obviously, training style and volume is going to matter as well. So if someone says they're training 3 hours a day, you might immediately think, wow, that guy's or girl's going to have a massive calorie burn there, so I'm going to have to put them on high calories. What does that training consist of? I've worked with powerlifters, I've worked with Olympic lifters who will be training for 3 hours a day, but an hour of that will be rehabilitation, prehabilitation, mobility work. An hour of that will be their actual technique and lifting work, and the other hour that might be the supplementary stuff where they build some volume. But if we were just looking at that as a 3 hour training session, we might actually overestimate their calorie consumption. So yes, we need to keep them fed in that period, but we're not going to need to put them on a high amount of calories compared to, say, a bodybuilder training with really high intensity activity, okay? So yes, they might be training for 3 hours, but within that 3 hours, they might only do 50 or 60 repetitions, which would be typically around about a third, probably less than a third of what most people would train in a normal bodybuilding session, okay? Yes, the weights are heavier, but the rest periods are longer, which is what they need to make their progress as well. So this actually helps in terms of weight loss. We can actually look at these factors to help us with weight loss as well. So keeping our clients with a positive relationship with food, keeping them focused on their goals, making sure they're seeing progress, and we can actually use training style and volume to manipulate their progress as well without changing necessarily their calorie intake. Again, we'll move on to that in a second. So, okay, here's an example. So we'll start with the amount of macronutrients. So again, this is goal dependent. So I talked about an endurance person is going to have a different protein requirement to someone who's a strength athlete. That's going to have a different protein requirement to someone who's dieting. So a lot of people talk about macronutrient ratio, so how much percentage protein, how much percentage carbohydrate, how much percentage fats. However, I think this is limited, and there's a reason for this. Protein is essential in the diet, okay? Fats are essential in the diet. If you're using ratios of protein, that means that as calories drop, then the percentage of protein within the diet also drops, or the grams of protein within the diet also drops. So how I like to work and how a lot of coaches like to work is to actually focus on meeting the essential requirements. Okay, so my protein will be, okay, someone comes to me and they want a strength training or muscle building program. I'm going to put them on 1.8 to 2 grams per kilogram of lean tissue of protein. Okay, so for a 100 kilogram person of leanish tissue, that's going to be around 200 grams of protein. Okay, and then on a contest prep, what I would do is, like I said before, I would swap their macronutrient ratios around. So I would say, okay, I'm going to increase their protein slightly. Why? Because a higher protein diet is going to keep them fuller, and it means you can then reduce the calories from your fats and carbohydrates without necessarily dropping their overall calorie intake. So let's put this into a practical example. I've got my 100 kilo bodybuilder, and their maintenance calories that I've calculated from their food diaries and so on and so forth is 4,000 calories a day. Okay, and on that 4,000 calories, they're consuming 2 grams per kilogram. So what I'm going to do then is I'm going to say, okay, I'm going to increase your basic level of protein to 2.5 grams per kilogram. We're going to add in a little bit of extra cardiovascular to increase calorific output, but I don't want to drop the calories too low too soon. So if I put them on 2.5 grams per kilogram, that is going to be that's 250 grams of protein, which is 1,000 calories because you've got 4 calories per gram of protein. So that's 1,000 calories and my 4,000 taken care of. So my fats are going to keep to 1 to 1.5 grams per kilogram. So let's just say we give 1 gram initially. Okay, so that's again another 900 calories because that's 100 grams of fat at 100 kilos times 9 because 9 kilocalories per gram. So that gives me what I've got left. I can then calculate carbohydrates, which are on non-essentials. Okay, so carbohydrates, I've got 2,100 calories left. So that's your 4,000 minus your 1,000 from protein minus your 900 from fats is 2,100. Then I'm going to divide that by 4 calories to get my grams. Okay, so like I said there, the bottom line on that is your calculated required calories is you calculate required calories minus your calories from fat minus your calories from protein equals your calories left for carbohydrate. Divide that by 4 gives you grams of carbohydrate, which in this case would be, I think, around 525 grams of carbs. Okay, now that might seem a lot, and if someone struggles to eat carbohydrates, what you might need to do is drop their carbohydrate levels. So as you could see there, that's around about 5 grams per kilogram. Okay, but some people might like to run lower carbohydrates because they find carbohydrates, especially lower GI carbs, starchy carbohydrates, quite filling. Okay, so you might want to drop their carbs slightly lower and increase their fats slightly higher. So we can adjust those energy variables there depending on whether they struggle to eat. But that's a good thing then, because actually what we can do then is actually keep our carbs slightly lower, but then it gives you less place to go with your carbs. So you still need to maintain there's enough carbohydrates in there to help replenish energy. Obviously, as dieting, it will feel like dying if you're on a bodybuilding prep, but as long as dieting is progressing, obviously then your energy from carbohydrates is going to drop, and it might drop from fats as well. Some people will prefer to run higher carbs, lower fats. Some people will prefer to run higher fats, higher carbs. This is where the skill as a coach comes in. You need to listen to your clients and figure out in what ways they're suffering. As an example, I tend to keep my fats lower than recommended here, simply because I'm very cortisol sensitive. I'm a naturally highly stressed person. There's key signs for this. We talked about the signs for cortisol sensitivity in the module in one of the previous modules. So I will tend to keep my carbohydrates higher because carbohydrates increase insulin. Okay, and obviously if insulin's higher, cortisol's low. I find that's a really effective way to help me sleep by taking carbohydrates later in the day, particularly when diet stress gets very hard. So I might only be on some days less than 50 grams of carbohydrates a day, but I will keep those carbohydrates before bed, which doesn't go against it goes against conventional wisdom. But this is what I'm talking about: experience and knowing your own bodies and listening to what your clients are telling you. You know, yes, carbohydrates might be raising insulin at the wrong times, but ultimately sleep is more important than you having carbs earlier in the day and not sleeping. So it's about getting the lesser of a few evils sometimes, which is definitely the case when someone is dieting, especially hard dieting. So I've now reduced my fats and carbohydrate, my energy intake, but the higher protein allowances will also mean that I'm going to preserve more muscle, particularly as calories get lower. So as my fats go lower and my carbs go lower, as those body fat percentages get lower and lower and lower, as we've now realized, our body is going to adjust to calorie intake as well. So I think I've said it before, if not I should have done, but for every kilogram of body weight we lose about 30 calories off a basal metabolic rate, okay, as a minimum. So you're going to get your thyroid adjusting, so your energy output is going to be lower, your energy expenditure is going to be lower, even though you're maybe preserving the same amount of muscle tissue as well, okay? So we need to think about this, and this is why we keep our protein quite high to help protect muscle tissue, because ultimately as our body fat gets lower, our body's going to start to want to reduce its metabolic rate, and one way of doing that is through thyroid, the other is reducing protein, where is protein stored? Within the muscles. So we need to keep our protein content high to protect muscle. So as our fats and carbohydrates go lower, you'll notice under the protein column I've said contest prep 2.5 to 5 plus grams per kilogram. Now 5 grams is excessive, okay? But if you consider our 100 kilo bodybuilder, if he was on a low carb, low fat day, let's say he was really pushing hard, you might find that 5 grams per kilogram is only 2,000 calories. For a 100 kilo lean bodybuilder training twice a day, that's not a lot of calories, okay? So consider that, yes, in the normal circumstances, 1.8 to 2 grams per kilogram is sufficient. But when dieting, we need to factor in the fact that our energy calories are a lot lower as well. If our energy calories are lower, there is a risk of eating muscle tissue. So not so much in the early stages of dieting, that's why we keep it around 2.5 for the macronutrient ratio benefits and for the metabolic output benefits and the reducing of hunger benefits. But as we get later on, we're going to want to increase it, one, to actually help reduce hunger so we've got some food, but also to actually help protect muscle tissue. Now there's a lot of controversy about this 2 grams per kilogram. There's some studies that have been performed which have shown that there's no difference in terms of lean mass gain between 2 grams per kilogram and 4 grams per kilogram in natural bodybuilders, okay? So this suggests that actually you're not going to grow any more muscle tissue by eating more protein. But what did happen was that these people gained leaner muscle tissue, so it gained less body fat. So it goes alongside the contest prep philosophy that by eating more protein, you're going to have the requirement to consume less carbohydrates and fats because protein is filling, okay? Whether it adds any more to metabolism in terms of metabolic demand isn't suggested by that study because there wasn't that much difference that you would think it would make that much. There wasn't that much difference to identify any real cause. But this then comes in as something that is kind of a secondary thing to this. But it's something that needs to be said if we're going to talk about bodybuilding, is that if we're talking about assisted athletes, that is likely to be higher, okay? Okay, those values are likely to be higher because, as we've discussed, testosterone, for example, increases protein synthesis. So you need to consider those things in if you do work with clients who are going to be assisted. So it's a big part of our industry. I'm not going to say a problem with our industry, but it is an issue, and it's something that we need to identify if we're going to diet people safely, is providing them with enough protein. So the real question is, how much does using anabolic steroids increase protein synthesis? And the real answer to that is it will vary from person to person. So this is where the skill comes in. I would suggest on a safer end of the spectrum that some people do, even bodybuilders who do use performance enhancing drugs, do overeat protein. I think, once you've dealt with your normal metabolic processes, protein synthesis is only going to be increased ever so slightly. So I would say start with 2.5 grams per kilogram and then go from there. Adjust it as is. If they're not gaining muscle and they're consuming enough calories, it suggests that their protein synthesis protein breakdown is outdoing their synthesis at that level, or it's not exceeding it at least anyway. So you need to then consider increasing protein in the diet. But I still think that bodybuilders as a whole do consume too much protein, except on contest prep when it's then required. Okay, so I think then we've got a basic idea of how to structure things from a bodybuilding perspective. Again, from a health perspective, or people who are just trying to lose weight, around 2 to 2.5 grams per kilogram is enough as a starting point as well. Again, you don't want to go too excessive with protein because obviously that can still be converted, like we've said, into energy using the pathways we've discussed previously. So getting that balancing point for protein is very difficult. And again, it comes with skill and experience and looking at a person and saying, right, okay, if they've got a fast metabolism, if they're a naturally leaner, skinnier person with less muscle tissue, they're probably going to eat muscle tissue pretty quickly. So we need to maybe have them on a bit more protein, even for our muscle building phases, even if fats and carbohydrates are higher as well. Okay, so what do we do then to adjust intake for fat loss and weight gain? So most research shows that a calorie deficit or surplus of about 300 to 500 calories is enough to initiate weight change. Okay, bearing in mind that there will still be sticking points. It's not like once you're in 300 calories deficit that you're then going to continually losing weight. Okay, there will be sticking points. Why? Because as we've discussed previously, our metabolism will adjust. So the leaner we get, there's things like leptin we discussed previously, there's things like thyroid which are going to adjust your basal metabolic rate, and they're going to encourage you to try and eat more food. So that's why dieting gets harder the leaner you get, because despite the fact your basal metabolic rate is slowing down, you require less energy intake, or hormones are signaling us to eat more food. Okay, so that's why hunger becomes worse, even though the calorie deficit relatively isn't as much as you would think it was, or different to the phase before it. Okay, so for deficits, this can come from food, typically carbs or fats. Like we say, we're going to hold our protein pretty constant, if not increase it. And then, or we can add exercise, so we can use HIIT, we can use LISS, or like I've said before, we can increase our training volume. So that can be adding in extra sets, so extra time in the gym. It can be reducing rest periods to add in those extra sets, or create more of a cardiovascular demand. Or if we're dealing with someone who's training at a relatively low volume, like a powerlifter who wants to lose body fat, we can simply just put them onto more of a bodybuilding style program to actually maintain leaner tissue. One of the advantages of using the Y3T program, particularly week 2 and definitely into week 3, despite the fact that the evidence is there to support that you can increase muscle in those training volumes, definitely in week 2 and in week 3, your training volume is high and your rest periods are so low, you're going to actually maintain a lower body weight, and you're actually going to keep your body using fuel at a higher level because of the intensity of those sessions. Okay, so by adding in those higher volume sessions in a week, or at least every couple of weeks, you can actually initiate weight loss without necessarily having to actually decrease calories, because you're increasing calorie output from training. But remember, too great a deficit can cause rapid alterations in metabolic rate. Okay, so putting yourself on 1,000 calorie deficit a day probably ain't a great idea, because you end up going to slow things down quicker and quicker and quicker and quicker and quicker. It's like a tongue twister, that. So the other issue with that as well is that your body can only lose so much fat in a day. So it doesn't matter how much of a deficit you're in, your body can only metabolize fat, adipose tissue, down into fatty acids at a certain rate. People who cut too many carbs can have issues as well, particularly in part of this deficit, because actually glucose is actually required for some fatty acid metabolism. So I'd always advise keeping some amount of carbs in, even if you are going low, to actually help fatty acid metabolism. For surpluses, for trying to create a calorie surplus to build muscle tissue, this can come from food, or the opposite, we can actually reduce our training volume. I wouldn't necessarily recommend that. I would always go with food necessarily, because in reducing training volume, you do risk then of not having the benefits in terms of the cardiovascular benefits that we've said. You can actually put extra cardio in to actually stimulate metabolism as well. So if you do a little bit of HIIT of a morning for 10 or 15 minutes, or a little bit of just go for a walk of a morning to actually create a slight calorie deficit, then you'll find that stimulates metabolism, so we can actually eat more of a surplus at that time and around our training. Issues that we talk about though are risk of becoming too fat, and this has implications for other hormones. So we know that adipose tissue will aromatize testosterone to estrogen, which obviously isn't good if we're trying to build muscle. Okay. Also, it will affect insulin, because if we get if we can become less insulin sensitive, we can start to have issues with that as well. It's interesting to note that if we get fat and then we start to lose weight, unfortunately, the same things seem to apply in terms of reductions of calories from our basal metabolic rate. So the fatter you get, or the fatter you start, the more obese you start, unfortunately, it doesn't matter you've got all that excess fat. When you reduce your kilogram of weight, you're still going to get the same calorie drop whether you're leaner or not, which is why a lot of people who are starting from very overweight are going to really suffer with hunger, and it's something they're going to have to control if they want to maintain a lower body weight, until they can get to a point where hopefully they'll be able to increase their calories slowly as they build more muscle tissue to increase their metabolic rate, in order to counteract those feelings of hunger that the body will be telling them to eat. Okay, so this is a really good reason to actually try and not, if you are in shape, not go on too dirty a bulk, as they say, to put on too much body fat. It's not recommended for a vast majority of your hormones. Will basically cause problems for you further down the line. So remember, in terms of adjusting these and reaching sticking points, that monitoring should be performed using weight and measurements, and the most effective way is to monitor changes visually. Everybody knows people who've dropped body fat and built muscle at the same time. Their weight may not change. Okay, so looking at weight, yes, it's an effective tool with someone who's obese. You'd expect to see the scales drop until visual changes can be seen. But for most people, it's to not get too obsessed with looking at the scales. There's loads of different reasons, particularly in women, their hormonal cycles will make their weight fluctuate a lot as well. So pictures are an effective way to monitor changes, and also keep an eye on strength. It's an indicator of muscle growth. So if strength isn't going up, they're not growing enough muscle. We might need to increase calories. Okay, even if it's not maximum strength, but strength at a relative volume. Okay, and it can also be an indicator of too abrupt a decrease in calories. If someone is dieting and they're losing strength rapidly, you're cutting too many calories. I've been guilty of this. Most people are. If I've been dieting, let's say for a holiday, and I've got 6 weeks and I'm starting from not a particularly good place, I'll think, right, okay, I'll cut my calories maybe by a little bit more than I should have done. And within 2 or 3 weeks of training, I've noticed that my strength in terms of volume and in terms of my max lifts is dropping. Okay, that's usually an indicator you're doing it a little bit too quickly. You shouldn't be losing muscle strength that fast. Okay, so obviously pictures can be challenging. So if you do have clients you're doing online or you can't see them in person, make sure they've got good lighting, make sure they know how to pose, make sure they're being consistent with their pictures, times of day, so on and so forth, and the foods they're eating around those times. And try and get to the point where, again, this comes with experience of having a skilled eye to be able to detect very small changes. This has gotten easier since modern technology with mobile phones, because the image quality is now good enough that you can detect those. A few years ago, it was quite difficult actually to track people's progress, unless they, because it just wasn't convenient, so it's difficult to chase people up. Now people really haven't got an excuse. This can be challenging for people who do have body issues, but again, this comes back down to developing a relationship with a client. If not, you have other options. Obviously, if they're that body conscious because they're overweight or they're too underweight, then weight and measurements are going to be of benefit in those people. So, like I say, using hip circumference, waist circumference, chest circumference, arm circumference, they can do that if that's a more comfortable way for them. So you can't bully people into doing this. But anyone who's going to go on a bodybuilding style prep diet for either muscle gain or weight loss is going to have to bite the bullet and give pictures, because it's the only real way to indicate what's going on in the body. Because like I say, people can grow into shows, people can over diet and lose muscle tissue, and it's only having a skilled eye by seeing those things you'll be able to see those things. So as always, our white slide shows that we're at the end of our module video. Hopefully that was at least a little bit interesting and it wasn't too confusing for you, and now you can start to put the pieces together to see how our body metabolizes food and produces energy, and we've talked about the various touched upon the various processes in terms of anaerobic metabolism and aerobic metabolism, and how our body actually uses those to regenerate ATP. And now you've had a basic understanding and a little insight into my mind, and a little bit of Neil's input as well in terms of how we structure diets and how we go from there with our clients. It seems really simple, and in essence it is, but the real skill comes with the experience of being able to understand what changes to make and when, factoring in all those other options as well. So when you meet with a client for the first time, if you are going to be doing nutritional programming with them, be aware, ask for things like food allergies, ask for things like aversions to food, things they just have disgust for, ask for, them to be as honest as they can about their relationship with foods, because those things, when you can tailor those things to a diet, are actually the real key things for getting adherence and getting results that are going to push your business forward. Anyway, thanks again for listening, and you will hear from me very soon.